Hello, my friends. Thanks so much for joining us back at the Galaxy YouTube channel. Behind us is the city of San Francisco. We're at the 34-story studio/suite that we're doing this from at Semicon West. Today, I am joined by Aronoff.
Nice to meet you.
Nice to meet you too. Thanks for coming here. And you are the CEO and founder of Tartan Silicon. Now tell me what you do.
So with Tartan Silicon Systems, what we do is we enable our customers to get new semiconductor products into market reliably and with high quality. And we work with our customers on, we've developed a set of analytics to manage quality and reliability of chips throughout the product life. And we've evolved from doing that to a new technology we've developed, which will actually predict failures of silicon devices in the field. And that's based on a proprietary and patented technology we recently developed.
Okay, and are these, is it like hardware boards, or is it chips, or is it all the above?
So our technology is a set of monitoring sensors that go on chip. And those sensors are read during wafer probe final test, and the data is also captured during field operation. And we build a machine learning model based on sample data, sample chips that we take through the lab and exercise until they fail. And we take that data to build a failure prediction model.
Oh my gosh, that sounds amazing.
So the key applications for our technology are those systems which, if there is a field failure, the cost of such a failure is very high. And so we're focused on the automotive markets, defense aerospace, as well as high performance computing.
Okay, so I have a question, because as at Galaxy, we have a software, it's PatMan, which is part average testing.
Mm-hmm.
What it does is find things that before it fails, you're getting rid of good parts in this case, before they become failures, because parts that are good but they're statistically different from others, regardless of the distribution, are known to be the ones that are going to be the first ones failing.
Right.
So on yours, you said you have these sensors that are on it. So it's hardware on hardware that's giving you the trigger of that failure?
Yes, our sensors create data based on the health of the chip, and that is processed through our machine learning algorithm.
That's okay. And so your IP is are those sensors that go into
that are on the sensors that go on the chip. Now, what I should mention is early on, as a lead up to developing that technology, we did do some work with Galaxy, where we used Galaxy to create a specific database that incorporated wafer data, that is the wafer acceptance test data, the watt data from the foundry, along with wafer probe data, final test data. And the project and the chip we were doing is one that we currently are managing for a customer. It's an interesting chip because we can identify each die and know where on a given wafer that die was from. And what we were able to do was build a machine learning model to predict which devices would fail at test for certain functional tests based on the wafer, the watt data contained within the chip.
Now your machine learning algorithms, have they unsupervised, or how has your machine learning developed and sort of changed over time?
So basically, the machine learning algorithms we developed, we process data of fully tested devices, good and bad, and like I said, we have to incorporate the wafer data, the watt data, along with wafer probe and final test data to predict which devices will fail. So the objective of all this is, when there's a yield issue with our customer, customer has one of three solutions he can do. He could change the design, which is not very likely to happen.
Because they're always right.
Well, no, it's very expensive. He can change parameters in the test program, which is one of the things that's very likely, and we do that. And the third item that can be done is we could find regions within wafer processing that we should direct the foundry to avoid. And as long as you can speak the foundry's language and tell them which types of parameters to tweak and understanding how certain parameters affect other parameters in wafer processing, then that can be a solution as well.
Okay, what year was Tartan Silicon founded?
2016.
Okay, and you must have a fab background.
Well, as you can tell from my white hair, lack of hair, I have over 40 years in
Got
this
less hair than
industry.
you. What are you talking about?
Yeah, but it still has color.
Barely. What?
but-
Raise a color.
Yeah, but exactly. But basically, my background has been in design and in the 1980s, what we used to call product engineering, which is working at the intersection of process and test and design to get products into manufacturing and have that go through smoothly.
My life was a product engineer before I came. Yeah, I was a product engineer for many years before I was recruited by Galaxy, for sure.
Okay,
Motorola, Medtronic, and all that good stuff.
So I call this an old man business. You have to be of a certain age to be doing this.
So it sounds like the value proposition is you're able to provide early detection of failures, which will save them money in the long run because failures cost money. Not only they cost relationships.
Well,
if you ruin the wrong
it's
ones.
not only finding them at test, it's finding, because you could have devices that pass. They will fail in the field over time because as the device is exercised, it will be subject to electrical, temperature, voltage forces that will cause the characteristics of the device to change. And that is precisely what we monitor and are able and use the measurements we get from our sensors to build our failure prediction models.
So if you used our pad on top of yours, would it be overkill?
No, basically what happens is our application and our metrics, our analytics reside on top of Galaxy. We do that today.
Okay. How did you arrive at this concept? You must have been working on something similar, and you're like, hey, I could just do this, and I'll just go off on my own. And
Well, it's a little simpler than that. An opportunity arose from from the employer that I had left, and when I left the Imagination Technologies, I had a couple contracts to put chips into production. So we started out kind of just doing the service of putting chips into production, and after you do that a while, you start to see that they do things that may sound good but don't naturally play well in a manufacturing standpoint.
Sure.
So one of the reasons we've developed not only our field prediction technology but also other monitoring technology capabilities we have is to address those issues in production. So we do have a way forward given the design to get a good reliable chip into production.
what do you think the biggest thing that separates you from anyone else?
I think the biggest thing that separates us from other people in the industry is the technology we have around monitoring device aging and predicting failures in the field.
Well, this has been great, Al. Thank you so much for joining us. For those of you watching, if you've liked this, go ahead and hit the thumbs up button down below. If you want to see some more videos, click the subscribe button down below. And if you want to see other interviews that we've done here at Semicon with this nice little view, or other areas like the ASMC conference, you can go ahead and click the playlist above that has all of our interviews on there. Al, thank you so much for joining us. We'll see you next time.